Greetings and welcome back. Today we're going to talk about the differences between shocks and struts and what their main purpose is. You've probably seen shocks and or struts on different vehicle applications and seen a difference between them. Mostly that a strut usually has a coil spring mounted to it. Now struts can also be of the modified McPherson suspension style where the spring is located elsewhere, but typically you'll find the spring mounted on the body of the strut assembly itself. Now connected to the strut, you may have a pivoting point at the top, strut mount bearing for the upper pivot point of the steering. They may be of the type that do not have a pivoting upper portion, like this one off of a Honda CR-V. And shocks, well, there isn't a whole lot to them. They don't do a lot other than the one function they're designed for, which is to dampen spring oscillations. Both shocks and struts are designed to dampen spring oscillations, especially with coil springs. They're the most susceptible to spring oscillations. So as those springs want to keep oscillating until they get to the low point and stop, we need a dampener to help that spring come to a rest. The main purpose of a shock or strut is to dampen spring oscillations. Here's an example. If the struts were not effectively dampening the suspension, the back of the vehicle would still continue to be bouncing. We should have one solid jounce down, up, and then come to rest. Even if the vehicle is designed to carry heavy loads, the result should be the same. A suspension strut assembly is a structural component of the suspension system. They're going to be more robust in design. They'll be heavier. They'll often have spring perches on them. Not only are they going to provide dampening for the suspension system, but they'll also be a structural and integral part of the suspension system. Shocks, on the other hand, only dampen the spring oscillations. They are not structural at all. An example of a strut assembly providing the structural connection between the upper pivot point of the steering down to the lower pivot point of the steering supports the vehicle weight and the other forces acting on the suspension system while the vehicle is driving. Struts are often the preferred method of supporting the vehicle load and housing the spring assembly in one convenient assembly. We can have an upper pivot point, a spring that carries the load of the vehicle, a dampening component, and a structural piece that connects to things like brake line brackets and sway bar end links and connecting to the steering knuckle of the vehicle, all in one unit, making this very attractive to different manufacturers to use and be able to engineer the system to handle all different kinds of jobs within one compact unit. So this saves space, cuts on cost of manufacturing, attractive to vehicle manufacturers. A shock is not structural at all. A shock depends on other links, or in this case the leaf springs that locate the axle. This is the front of our front leaf spring. And then it goes all the way to the rear perch, and that locates the axle, fore and aft. The shock mounts to a tower and does not support anything else other than the job of dampening the spring oscillations. Here's another example of a shock application. The shock is not a structural component of the vehicle. This shock can be removed with the vehicle weight on the ground and nothing would change. It only dampens the spring oscillations. The suspension system doesn't rely on the shock for anything structural. Instead, we have an upper control arm with 2 points of contact, one back here and there on the frame, and then another at the ball joint. Same with the lower control arm. The lower control arm connects the lower ball joint to the chassis, and through those connection points offers our structural integrity of the suspension system. That, coupled with the torsion bar suspension, allows this vehicle to sit at ride height. The shock, again, supports none of that. You will usually find shocks used on a solid axle application or a heavy duty application with multiple links for the suspension. On the more compact, simpler designs, like for compact cars and SUVs, Struts may be the more common option from the manufacturer's development and manufacturing standpoint. Shocks and struts have moving internal components to them that dampen spring oscillations by moving valves through fluid. Usually it's made with really thin pieces of metal that deflect one way or the other and allow fluid to go past them and control that speed. These will wear out, and typically these wear out between 60 to 80,000 miles, and most vehicles are driving around on dampeners, whether they're struts or shocks, that are older than 60 to 80,000 miles. So this is important to pay attention to when it comes to mileage on a vehicle and what you're servicing and during your inspections. Also, when these fail, the fluid inside can leak and come out, and you'll see it underneath, and you'll see fluid or wetness coming down the body of this. If you see wetness, it's failed and it's then a repair. If these are recommended before you see any visible signs of failure, it is a maintenance item and it is not a repair. Once you see moisture or you see damage occur to it, replacing these is then a repair. So the difference between maintenance and repair. Maintenance is proactive, repair is reactive. Replacing these isn't very complicated. Depending on the vehicle, there may be more labor involved with one versus the other. There's usually a lot less labor involved with replacing a shock assembly. It's usually one fastener at the top and one fastener at the bottom because it is only taking loads from each end. That's it. On a strut, however, especially a strut that has a coil spring mounted to it, which most have, has the upper mount, the lower mount, the upper seat mount here on the assembly, and the coil spring is not completely unloaded in the strut assembly when it's removed from the vehicle. So this spring is actually loaded partially before it's installed in the vehicle. This has spring pressure on both perches. So in order to replace the strut assembly, if you're not replacing the complete spring and strut assembly as one whole unit, then you'll need to compress the spring with a spring compressor and understand the safety measures taken in order to service and replace the strut assembly. On some vehicles, like our example here, have a pivoting function on their strut. That's usually done through the top mount bearing. So the top mount bearing is serviced when the spring is compressed and removed. That center stud comes up through the center of the strut mount bearing, or the top mount bearing, and mounts and holds the spring pressure in place. On the bottom side is usually the seat or the insulator for the spring, dampens vibrations, or it may be separate from the actual insulated piece, like on this one. When you are servicing the strut body for replacement, I highly recommend including the top mount bearings if it's equipped with pivoting top mount bearings at the same time. This will avoid future disassembly and replacement of that top mount bearing should it fail sometime after the strut has been replaced. Typically on struts, since they tie in structurally to the suspension system, right here at these two bolts for one, will require an alignment if these are replaced. Since shocks are not a part of the structural component of the suspension system, they do not necessarily require an alignment once they're replaced. Since they can be removed and installed with a vehicle weight on the ground, if you can get to them, it doesn't affect the alignment. The structural component of the struts do often affect the alignment. Sometimes you'll have a strut, like this one off the CRV, that does not have any pivoting components to it, where the vehicle load is carried through this spring and it loads from one control arm to the chassis. But it does not pivot with the steering. The pivoting is done between the upper and lower control arm ball joints instead of through the strut assembly and top mount plate, or a strut bearing. The difference being, when servicing these two different assemblies, is the top mount bearing on one can rotate and line up with the mounting holes when you're reinstalling it back into the vehicle. Not the case on one that does not have a bearing on it. These should be marked for reference before disassembly. That way, when they go back together on reassembly, they're put together in the correct orientation to where the holes line up on top and the hole on the bottom lines up with the lower component. Let's go through the process of replacing and servicing a strut assembly. Before I mount this in the spring compressor, I want to put a couple reference marks in. Normally, the strut body is going to be replaced. So it doesn't help if I put any reference marks on the part that won't be going back on the car, or that I'm going to be mounting the spring back to. I'm going to reuse the spring. The locations that I'm going to use for reference are going to be in relation to the mounting. So our lower bolt hole right here, I put a mark on the spring that lines up with that hole. And I put a B right here to signify the bottom of the spring. That way I don't get it out of its correct orientation and put it in upside down. At the top, there's the top mount plate and this tab hanging off one side, and it looks like a generally symmetrical plate, but I don't know for sure, so I'm just going to mark it upon removal. This does not pivot. This does not have a bearing assembly on top, so unless it needs to be replaced with the lower spring, unless it needs to be replaced along with the strut body, then I would recommend replacement. But since there's no bearing there, it's just serving as a rigid upper mount, there's no reason that I see on this one to replace it. So I lined up my mark right here on the spring to line up with these two mounting bolts. So linear alignment with those down to the spring, and I wrote a little T for top. So this will help for disassemble and reassembly. So let's put this in the spring compressor. Get everything adjusted correctly. Because once this spring is compressed, we don't want to hang out anywhere near the upper side of it, because if this launches, it's going to produce energy in both directions, up and down at the same time, and you want to be very clear not to put any part of your body in the way of that spring if it were to unload. And we're looking for a nice even compression of the spring as we compress it. Okay, so that spring is now compressed. Now this upper plate is spinning, so what I'm going to do is back the spring compressor off a little bit and put some tension on that plate. Remove our upper plate assembly, and then unload the spring. Coil spring removed. And then the strut body can be removed. So these will sometimes come with all new dust boots and bump stops. This actually doesn't have a bump stop on it. There's usually going to be a rubber stopper that rides on this piece right here. So as this is compressed to its limit, it's going to cushion on the rubber stopper rather than bottoming out on the valves inside and destroying the internal components of this. So this does not have a bump stop on it. So I apologize, I'm not going to be putting a bump stop on it for reassembly, but for all intents and purposes, let's say this is the new strut cartridge ready to go back in for reassembly. Put the pieces back together in reverse order. You want it as straight as possible. So going back together, I have my B right here and my alignment mark to line up with the lower mounting hole right here. And the coil end terminates right here. So that's also an indicator for where the spring is supposed to go on the strut body. So if you see on the strut body right here on the strut body is a little bit of a step. That accepts that uneven ending of the coil spring where it terminates. Also on the spring is the insulators. So these rubber pieces that go against the spring and rest against the coil help to dampen any noises that may occur from the spring deflecting against another metal component. Got my bottom line, got my bottom mark lined up. Now it's time to compress the spring, and then we'll put the upper mount on and tighten the assembly back together. Here's my mark on this side. I'm gonna line it up with the one that I painted white. Being very careful since that spring is under pressure and loaded. And these nuts should always be replaced with a new nut. Inside the top of this locking nut, there's a nylon insert that deforms and helps hold onto the threads and grabs onto the threads once it's threaded across it. Now this style should always be replaced. If you cannot replace it, if you cannot find a replacement, or there's nothing available and you have to reuse it, always use red Loctite on a nut if you have to reuse it. The best case scenario is replace it with a brand new nut that has a new locking feature on it. So I just put a little drop in there, and that's enough. You don't need to coat the entire threads with red Loctite. And this acts as this acts almost as a bonding agent, almost an adhesive, but it solidifies after it's been tightened to spec, and that red Loctite will set up and it will form a nice holding feature to the nut to prevent it from backing off. Essentially, it restores its locking ability. Like I said, it's not ideal. We'll thread that on by hand. And then we'll tighten that down. And release the tension on the spring. And then you're all back together. Double checking that your reference marks line up. Lower hole, reference mark. Bolts across the top, tab, reference mark. So this is back to the exact orientation it was when I took it apart and should go into the vehicle. If these were not lining up with the mounting holes when it goes back into the vehicle, top or bottom, then this would have to be recompressed and then clock this whichever direction would need to be going clock this in whichever direction is needed in order to get them to line up. But then at that point, you're going back to the vehicle, back to the spring compressor, back to the vehicle, and it's going to take time. So the more accurate your reference marks are, the more reliable it will be going back in the same way it came out, and in the long run, taking less time to perform the task or to do the job. Once you've done one, it's time to do the other side at least, because these are always replaced in axle pairs. A lot of the times, the rears are the same age as the front, so you're doing all 4 of them. So replace all 4 strut assemblies, ship it off to alignment, torque all your fasteners to specification. This should actually be torqued to a specification. You can see the Allen hole right there for an Allen socket or an Allen wrench. And I don't have the through hole socket set to put a torque wrench on at the same time as holding the stud from spinning in order to torque these to spec. So I tightened it with the air. It's not advisable. It's how a lot of people do it in industry, and it's how I was forced to do it for this example without having the tools here at my house shop. So apologize for any misdirection there. I will be sure to cover that in person when we are working on these assemblies in lab. So to recap, the job of a strut, sometimes, most of the time, holds the spring, has a bump stop in it, it dampens, it's a structural component piece of the steering and suspension system. It may or may not have a pivoting point on top, and as it wears, you typically will need to compress the spring in order to replace the strut cartridge and release the tension on the spring on the new one. Job of the shock, it's almost like Job of the Hut. Job of the shock absorber is to dampen spring oscillations. So that's the only thing it has in common with the strut assembly, and that's the only thing it does. It only dampens spring oscillations in the suspension system. Doesn't do anything else. It's a lot lighter, not structural. You can remove and replace these with the vehicle weight on the tires. I hope you learned something from this video. We'll get on to the next one. Thank you.